Hello, today I'm going to go through catalysts and how they affect rates of reactions. Right, some of you may know already that catalysts speed up the rate of a reaction, but there's some extra detail that you need to know about this. So, you need to know that initial statement said catalysts speed up rate of reaction. Okay. The other thing that you might not be aware of, however, is they do not get used up themselves. So, for example, amylase in the mouth is a catalyst for speeding up reaction. The amylase does not get used up itself, it still remains. So, amylase is an enzyme. Enzymes are biological catalysts. Now, catalysts are really important in industry. Okay, they can make reactions a lot faster and therefore add that economic edge where you're not having to pay people wages for it to last a long time. You get your product quicker. Right, you can just learn that how they work is via this sentence here. So, they need to lower the activation energy to make the reaction quicker. Okay. How do they work? They provide an alternative reaction pathway, and that alternative reaction pathway has lower activation energy. Now you can stop there if you want. Okay, that satisfies the criteria for explaining how they work. Alternative reaction pathway means that it finds a different route for the reaction to happen, and I've given an example here. Let's say in industry we want to mix together two products, A and B, to make D to sell to other people, such as a fertiliser, for example. Okay, A plus B and leaving it to go to D takes ages. Okay, it takes a long time. However, if we throw in catalyst C, we can do a chain of reactions to make D quicker. So let's say that we chuck in catalyst C, okay, with reactant A, and we make a product known as AC. Okay. Note that that has not been used up at any point. Then that AC reacts with the other reactant that we have, B, and makes a big combination called ACB. All of a sudden, that ACB reacts and leaves you with product D, all at a lower activation energy. It looks like it's a multiple step process, and that's because it is, okay? But if all this is occurring with lower activation energy, you end up with product D quicker. This is not something that you need to be aware of until A level. However, I don't like to see it on the spec where it just says alternative reaction pathway and then doesn't explain it. So that's it explained. You may be asked to do a reaction diagram for this, okay, and the use of catalysts. So let's say we've got an exothermic reaction where we've got some reactants here and we need the products down here. Now, if we don't have a catalyst, a large amount of activation energy is required, okay? So our activation energy is that hump there to make them react, okay? However, if we introduce a catalyst, your activation energy is lower. And that's the difference, okay? That you don't need as much energy to make it react, so therefore you speed up the rate of reaction. This is an exothermic reaction because energy is released, and there is our change of energy as that chunk. And that's catalyst.